Hello students, welcome to Engineering Guru. We provide simplified video lectures for your university exams. Now from Engineering Mechanics, the topic we are going to learn is regarding equilibrium of force system. A body is considered to be in equilibrium if the object or body's initial position is not disturbed due to any set of forces. Consider there are several forces acting on a body. If resultant of all different set of forces acting on a body is zero, then the body is said to be in equilibrium. Equilibrium is differentiated into two categories: static equilibrium, dynamic equilibrium, depending upon whether the body is at rest or the body is in motion. The condition of equilibrium happen to a body when it is at rest. That is called static equilibrium. The condition of equilibrium happen to a body when the body is in uniform motion. That means the body is moving with uniform velocity. Then if the body is moving with uniform velocity but it exhibits equilibrium, then it is called dynamic equilibrium. Principle of equilibrium: a stationary body is subjected to coplanar forces, then the body is said to be in equilibrium if it satisfies two conditions. The first condition is resultant of all external forces acting on the body is equal to zero, and the resultant of all external moments about the body is equal to zero. If these two conditions are satisfied, then the body is said to be in equilibrium. Equations of equilibrium will consider 2D, means coplanar system. For that, summation of Fx is equal to 0, that is sum of horizontal forces is equal to 0. Sum of vertical forces is equal to 0. Summation of Fy is equal to 0. And also sum of moments on x-axis is 0 and sum of moments on y-axis also said to be 0. When it is related to 3D problems, space problems, that is non-coplanar system, all the three axes are to be considered. Sum of Fx is equal to 0, sum of Fy is equal to 0, and also third plane, third axis, sum of Fz also is equal to 0. And also for this we'll consider moments on, sum of moments on x-axis is 0, sum of moments on y-axis is 0, and the sum of moments on z-axis also said to be 0. For coplanar concurrent system, sum of forces on x-axis and sum of forces on y-axis both are considered to be 0. Then the body is said to be in equilibrium. And for coplanar non-concurrent system, all the four are to be satisfied. That means sum of forces and sum of moments both must be equal to 0. That is for coplanar non-concurrent force system, and the object or the body is said to be in equilibrium. The same we can apply non-coplanar concurrent forces. Non-coplanar concurrent force system, sum of forces on the all three axes are said to be 0. Then non-coplanar non-concurrent force system, along with the forces, moments are also considered to be 0. Sum of forces as well as sum of moments both must be 0 for non-coplanar and non-concurrent force system. Free body diagram. It is a diagram which represents all forces acting on an object. This is the diagram which is required to convert physical condition of a body into a mathematical problem, into a mathematical representation of forces. That is said to be free body diagram. And it was in simple, we name it as FBD, free body diagram. And this FBD will represent all types of applied as well as reactive forces. Applied forces are the forces which are acting on the body and impart external action. The forces which cause action, those are applied forces. The forces which cause reaction due to internal force, Those are called reactive forces. And also the free body diagram shows all kinds of angles. Shows all angles between forces. Conditions to be considered while plotting a free body diagram, especially related to reaction with respect to reaction due to internal force acting on the body. Reaction or the first condition is the reaction force always acts perpendicular to the plane. That means at 90 degrees. And the second condition, this reaction force always act at a point towards the body. That means consider this is an object placed here. This is the plane. Now this is the reaction force acting on the object exactly which is perpendicular to the object, and also the arrow is showing towards the object. So while representing free body diagram, you need to remember these two conditions. Very important. First one, reaction force must be always perpendicular to the plane. Second one, the arrow of reaction force is shown towards the object. Let us consider few examples related to free body diagram. The first one, a ball resting on floor. This is a ball resting on the floor. Now to plot free body diagram, first we need to show x and y axis. This is positive y, this is positive x, negative y. Now here remember, always weight of the body pulls downward direction. So the weight of the object acting towards downward direction W, and also the ball is in contact with the floor. Now the reaction force shown on the wall by the floor, that is showing reaction force RA. The second one, a ball suspended with a rope resting against a wall. Consider this is a wall and ball is resting against the wall because it was suspended by a rope from here. This is x and y axis. Again, as I said already, always weight of the object act downward direction. Weight of the ball W, and the ball is in contact with the reaction force with the wall. So reaction force RA acting in this direction, and due to the rope string, tension is created in the ball. Tension imparted T. This is free body diagram related to the ball suspended with rope resting against the wall. The third condition is the ball is resting against both the wall as well as floor. This is the wall and this is the floor. In the previous case, there is no floor. Now the ball is resting against both wall and floor. A string is traveled from the wall and the ball is taking rest, touching both wall and floor. And reaction force acting here, consider it as RA, and reaction force acting here, consider it as RB, and the weight of the ball W, tension caused due to the string T. Consider this is x and y axis. The weight is acting downward direction W. Reaction force RA and reaction force RB. Then tension is shown T. This is a free body diagram related to this ball resting on the floor and wall suspended with a string. Fourth condition, a weight supported by two strings. Consider this is the weight W and it was supported by two strings A and B. Now weight of the object W acting downward direction, tension due to the string B TB, tension due to the string A TA. These three forces we have to show in the free body diagram. This is x and y axis. Now the force due to weight of the body W acting downward direction, then TA due to string A, tension due to string B TB. This is free body diagram for this weight. The next one, a weight supported by roller and knife edge. This is a weight supported by a roller and a knife edge. Here the reaction caused due to roller RA, reaction caused due to knife edge RB, and weight of the object W. Now free body diagram, x and y axis, weight is acting downward direction W, reaction A acting RA, reaction B acting RB. This is free body diagram. The next one, a ball placed on an inclined plane and resting on a wall, and also inclined plane. Consider this is the wall, this is inclined plane, ball is taking rest. The inclined plane is located with an angle theta to the horizontal axis. Now if you are going to draw FBD, this is x and y axes. The weight of the ball acting downward direction W. The reaction due to wall, consider RA, acting in this direction. The reaction due to inclined plane, this is reaction due to inclined plane. This inclined plane reaction is acting in this angle RB. And what is the angle with which the RB is formed? That is very important. Determination of angle. So as per the given diagram, this is the inclined plane which has formed an angle theta with the horizontal axis, and the object ball is located here. The very important thing you need to remember here, always reaction is perpendicular to the plane. Means reaction is always at a 90 degrees angle to the plane. So this is the reaction exactly perpendicular to the plane. So if you take this is inclined plane, reaction is acting exactly perpendicular to the plane. What is the angle here? Perpendicular to the plane means the angle is 90 degree, and here the angle is theta. When you draw a straight line from here, now this is a triangle, this is angle theta, this is 90 degrees, then the angle here is 90 minus theta. So for a triangle, when we consider already inclined plane with horizontal axis theta, and this is 90, so that this angle is taken as 90 minus theta. But this total angle with respect to reaction force to the plane, that total angle, what is the total angle? Total angle is 90 degrees. Then what is this angle? This is said to be x. What is the value of x? We consider 90 degrees is equal to 90 minus theta plus x. So what we can write down? X is equal to 90 minus theta. X is equal to theta. So if you draw a free body diagram here, now reaction will travel with an angle of theta here, so that opposite to that angle is also said to be theta, and this is 90 minus theta. Opposite to that also is considered to be 90 minus theta. So the angle is determined, considered as theta. So you can write down here as a horizontal axis angle is said to be theta. Now this is said to be theta, and this is said to be 90 minus theta. For inclined plane, horizontal axis angle is theta. Then for reaction, vertical angle is theta and horizontal angle is 90 minus theta. The very important point you need to remember here, if the inclined plane is formed with an angle theta, for the reaction force R, the angle theta is taken on vertical axis and the 90 minus theta is taken on horizontal axis. Lamy's theorem or sign rule, for a three-force system, for concurrent coplanar force system, which number of forces are 3. Let's take one example. 3 forces from single point A, B, C, forming 3 angles, alpha, beta and gamma. The angle between A and B is gamma. Angle between B and C is alpha. Angle between A and C is beta. But remember, sum of all 3 angles is equal to 360 degrees. Now, according to Lamy's theorem, which is applicable for a concurrent coplanar 3-force system, then force in any direction is proportional to the sine of the opposite angle. For example, when we consider force C, beta and alpha are adjacent, gamma is opposite. So force C is proportional to the sine of the angle gamma. Then force A, beta and gamma are adjacent, opposite is alpha. A is proportional to the sine alpha. We take force B, opposite angle is beta. So B is proportional to the sine beta. And we equalize this with a constant take a constant k. Then we can write down A is equal to k sine alpha, B is equal to k sine beta, C is equal to k sine gamma. If we write down the formula for k is equal to A by sine alpha, that is equal to B by sine beta, that is equal to C by sine gamma. This is the formula related to Lamy's theorem to determine 3-force system resolution. We can write down the formula. Ratio of force to the opposite sine angle is constant. So we remember the formula from this. The ratio of force to opposite sine angle is constant. So we'll explain Lamy's theorem with respect to one numerical example here. This is a 3-force system and all forces act at one point. Coplanar concurrent force system, and force 3 is 300 newtons. Estimate force 1 and force 2. The angles are provided 45 degrees and 45 degrees. Angle of force 1 with respect to x-axis 45 degrees. Angle of force 2 with respect to x-axis is also 45 degrees. So as it was a 3-force system, will follow Lamy's theorem. If it is more than 3 forces, n number of forces are there, then we'll solve according to resolution method. Now we need to solve for F1 and F2. According to Lamy's theorem, the formula is A by sine alpha is equal to B by sine beta, that is equal to C by sine gamma. Take this is C, this is B, and this is A. So what is A? A is F2 by sine alpha. It is alpha opposite angle to F2. And this angle will consider this is here to here, this is 90 and this part is 45. So what is that? Now alpha is equal to 90 plus 45, 135 degrees. So sine 135 degrees. And B, what is B? F1 by sine, it is beta opposite to B. So this is 45 and this is 90 total. Total will consider 135. So beta also we can write down 90 plus 45, 135 degrees, sine 135 degrees. C, what is C? C is F3 given already, 300 by sine gamma. What is gamma? We don't know. It was not provided. This is not provided, gamma. But we have the formula alpha plus beta plus gamma is equal to 360 degrees, which is the total angle for a circle. 135 plus 135 plus gamma is equal to 360. So gamma is 90. Sine 90 degrees. Now if we take F1 by sine 135 is equal to F2 by sine 135 is equal to 300, because sine 90 is equal to 1, that is equal to 300. So we'll consider A is equal to B is equal to C. That means A is equal to B, B is equal to C, so A is equal to C. So first we'll take A is equal to C. F1 by sine 135 is equal to 300. F1 is equal to 300 into sine 135 degrees, whose value is 212.13 newtons. Now same we can apply B is equal to C. Same we can apply A is equal to B. F1 212.13 by sine 135 degrees equal to F2 by sine 135. So what is F2? F2 is also 212.13 newtons. So this is the answer for F1 and F2. Now numerical questions related to equilibrium of force system. First question, a lamp weighing 8 newtons suspended from ceiling, this is ceiling, by a chain. It is pulled aside by horizontal cord. This is horizontal cord which is pulled aside till it makes an angle of 45 degrees. Find the tensions in the cord and chain. So for this, first we are going to draw free body diagram. Now the tension induced by cord, this is TC, tension induced by cord. The load W acting downward direction 8 newtons. And then the chain with an angle of 45 degrees to horizontal. This is a tension due to chain. This is a tension due to cord. Only one angle is given 45 degrees. How many forces are there? 3 forces. Due to weight 8 newtons and due to chain and cord 3 forces. So we'll solve according to Lamy's theorem. According to Lamy's theorem, we'll have the formula A by sin alpha is equal to B by sin beta is equal to C by sin gamma. Now the weight is taken as C. Tension due to cord is taken as B. Tension due to chain is taken as A. Tension due to chain A divided by sin opposite angle to chain. This is exactly perpendicular. We'll consider it as a 90. So sin 90 degrees is equal to, what is B? Tension due to cord. Then opposite to cord. This is opposite to cord. So this is a 90 degrees, exactly perpendicular. 90 plus 45. Opposite angle to cord. That is 135. Sin 135 degrees. That is equal to C, 8 newtons. Opposite to C. This is y-axis. This is a 90. And this is 45 because this total is 90. Out of 90, 45 is gone. 90 minus 45, that is 45. Or we may take alpha plus beta plus gamma is equal to 360 degrees. Alpha is 90, beta is 135, gamma is to be determined. So gamma is equal to 135 degrees. This total is taken as a gamma, sin 135 degrees. Now consider it. Tension due to chain by sin 90 is equal to 8 by sin 135. So solving, we have tension due to chain is equal to 11.315 newtons. Then tension due to cord by sin 135 degrees is equal to 8 by sin 135. So sin 135, sin 135 cancelled. So tension due to cord is 8 newtons. So answer is tension in the chain 11.315 and in the cord 8 newtons. Then second question, a weight of 600 newtons, this is the weight W, supported by two chains A and B as shown in the figure. Find the tension in each chain. So when we draw free body diagram, X and Y axis are taken. Now weight is acting downward direction 600 newtons. Then B, this is tension in B with an angle of 60 degrees. Tension in A with an angle of 30 degrees. Now again, how many forces? 3 force system. So again we follow Lamy's theorem. We write down the same formula. A by sin alpha is equal to B by sin beta is equal to C by sin gamma. Now TA opposite to TA, this is 90 degrees and this is 60 degrees total. 90 plus 60. So alpha is equal to 90 plus 60, 150. TA by sin 150 degrees. Then B, TB opposite to B, again this is 90. 90 plus 30, 120. TB by sin 120 degrees. C is nothing but 600 by this angle is to be determined. So we'll have again alpha plus beta plus gamma is equal to 360. 150 plus 120 plus gamma is equal to 360. So gamma is equal to 90 degrees. Sin 90 degrees. Now TA by sin 150 is equal to 600 because sin 90 is taken as a 1. So TA is equal to 600 into sin 150. The value is 300 newtons. Same we can write down TB by sin 120 degrees is equal to 600. Same TB is equal to 600 into sin 120 degrees. that is equal to 519.61 newtons. So tension in the chain A 300 newtons, tension in the chain B 519.61 newtons. Coming for the next problem, two equal loads 2000 newtons and 2000 newtons are supported by a flexible string A, B, C and D at points BC as shown in the figure. Find the tension in the positions AB, BC, CD. When we plot free body diagram, this is BC. Consider this is x-axis and this is y-axis. Now the loads are acting at this point 2000 newtons and 2000 newtons. Then there is a reaction at BC acting towards this direction, and there is a reaction due to A at this direction. Now the angle here is taken as 30 degrees and the reaction towards D and the angle here is considered as 60 degrees. But the total angle at this location is 90. So we'll conclude this angle is 30. Same manner, total angle here is 90. So we'll conclude this angle is 60. So angle of A towards horizontal axis is 60. Angle of D towards horizontal axis is 30. This is 90. This is also 90. And for this point, BC act in this direction. For this point, BC act in this direction. Now we can differentiate it into three force systems. How can we differentiate three force systems? Three force systems at two groups, at B and also at C. Take this point, force 1, weight, force 2 and towards C, force 3. And at C again we have 1, 2 and 3. So we are differentiating the system into three force systems. First three force system at B, second three force system at C. Again we'll apply here Lamy's theorem. What is the formula for Lamy's theorem? Same. A by sin alpha is equal to B by sin beta is equal to C by sin gamma. Now force system at B. If we plot a free body diagram with this, tension at BC, this is load 2000 newtons, tension due to A to B, TAB. As already we have shown the angles, this is 90 degrees and it was mentioned here towards horizontal axis, this is 60. So it is total, this is 90 plus 60, this is total 150. So we can write down this as 150 degrees. Then remaining alpha plus beta plus gamma is equal to 360. Then 90 plus 150 plus gamma is equal to 360. So what is gamma? 120. This is taken as 120. Now consider A is tension at AB divided by sin 90, because opposite to AB 90 degrees, that is equal to tension at BC divided by sin 150, because opposite to BC, this is the angle opposite to BC, that is 150. It is equal to load 2000 newtons divided by sin 120, opposite to 2000 newtons load 120. So now we'll consider TAB by sin 90 degrees is equal to 2000 by sin 120 degrees. TAB is equal to 2309.4 newtons TAB. Then TBC by sin 150 is equal to 2000 by sin 120. Solving, we have TBC is equal to 1154.7 newtons. So we got TAB and TBC. Then using force system at C, will determine TCD. We need TCD. For that we are using force system at C. Now this is TBC, which is already determined 1154.7. Then load 2000 newtons traveling downward direction, TCD. When we take the angles, when we consider the angles, this is a 90 degrees perpendicular. This total 90 plus 30, 120. This is 120. Then sum of all angles is equal to 360. 90 plus 120 plus x. So So it is remaining x, that is 150. So we'll consider this as 150 degrees. Applying Lamy's theorem formula, tension in BC, sine of opposite angle. So tension in BC and its opposite angle is 120. Sine 120 is equal to TCD. Opposite angle is 90. Sine 90, that is equal to 2000. 2000 by opposite to 2000, 150. Sine 150. We already determined TBC, so we don't want TBC. We'll take TCD. TCD by sine 90 is equal to 2000 by sine 150. So solving, we have TCD is equal to 4000 newtons. So already we have derived TAB, TBC. What is TAB? TAB 2309.4 newtons. TBC 1154.7 newtons. And just now derived TCD 4000 newtons. Then next problem. The same model like the previous, but angles are not provided. Distances are provided. Based on that, we need to determine the angles. Find the tensions in the wire of the shown figure. Also determine weight under equilibrium conditions, W. The previous question, both weights are given and equal weights. Here weight also not at all provided. So first, again when we draw FBD, free body diagram. This is a chain BC, x-axis, y-axis. Now at B, the force acting vertically downward 3 kilonewtons. And tension due to string A, TA, acting with an angle of theta 1. Tension due to string D with the same angle theta 1. When we take this triangle, the height of the triangle is given 5 meters. And this is 7 meters. Now if you consider theta 1 using sine theta 1 formula, sine theta 1 is equal to 5 by 7. So theta 1 is equal to sine inverse of 5 by 7. That is 45.58 degrees. So we have this angle as 45.58 degrees. And this is, we know, 90 degrees. This is 45.58 degrees. Again, this is said to be 3-force system. Again, forces are differentiated into at B, like previous problem, and also at C, using same Lamy's theorem. It is formula for Lamy's theorem. Force by sine of opposite angle. We have given the formula. A by sine alpha is equal to B by sine beta is equal to C by sine gamma. Now regarding forces at B, first when we plot a free body diagram, this is tension in B to C and load, weight of the object given 3 kilonewtons downward direction and tension due to A. And we will represent this with the angle 90 degrees. And regarding this angle, already we have the angle here 45.58 and this is 90. What is total? 90 plus 45.58. 90 plus 45.58. 135.58. About this angle, we'll consider 360 degrees is equal to 135.58 plus 90 plus x. X is equal to 134.42 degrees. 134.42 degrees. Now applying the formula. Tension at A, TA, by opposite angle. What is opposite angle? 90. Sine 90 is equal to tension due to B to C, TBC. The opposite angle sine 135.58 degrees. Then load is 3000 newtons by sine opposite angle 134.42 degrees. Now first condition, TA by sine 90 is equal to 3000 by sine 134.42. Then after solving, we'll have TA is equal to 4200 newtons. Then second one, TBC by sine 135.58 degrees is equal to 3000 by sine 134.42. And when you solve, TBC is equal to 2930 newtons. So we got TA and TBC. And second one, forces at C. When we plot FBD, this is TBC, which is already derived 2930 newtons. Load W acting downward direction, and it is to be estimated. TD, this is also to be estimated. Now when we take the angle, this is a 90 degrees. So this is a 90 and this is a 45.58. What is the total? 135.58. Same we'll take here, 135.58. Then remaining 134.42. Now TD by sin 90 is equal to TBC by sin 135.58, that is equal to W by sin 134.42. TD we have to determine by sin 90 is equal to TBC. Already we got TBC 2930 newtons by sin 135.58. Solving, we have TD is equal to 4180 newtons. Then second one, TBC by sin 135.58. It is TBC 2930. That is equal to W by sin 134.42. Now solving, we have the load applied, weight W is equal to 2989 newtons. We have determined all the tensions and load applied at C.